Hello ladies and gentlemen, welcome to a short video over the negative exponent property. Call it short because we really just want to hit this last rule in your notes, go over two of the four examples that are there, and we'll save the other the other two once we see each other in class again. This will round up our notes, round up our stuff over 7.2, and then give us one more day to still review and cover all this stuff in more detail and finish polishing off the rough edges. So, last rule, the negative exponent property for any non-zero integer. So this works for anything other than 0 as a base. For any non-zero integer raised to a negative exponent, fill in negative here. For any non-zero integer raised to a negative exponent, take the reciprocal. That's reciprocal. For those of you who still like to sound your words out, such as myself. Now, what does that mean when we're taking the reciprocal? If you remember, that means we're flipping the fraction. So if we have something like 2 to the negative fourth, and we need to take the reciprocal of it, well, this is really like 2 over 1. So now we're going to make it 1 over 2. But instead of it being the negative fourth power, it's going to be the positive fourth power. And that's the whole purpose of doing this, is to simplify it so we don't have any more negative exponents. There's nothing wrong with negative exponents, but they're a little more complicated to deal with. Typically, we want to get rid of them. So when we say simplify, this is what we're talking about. Now, the other side of the coin is if we have something like 1 over x to the negative fourth. Well, that reciprocal is going to flip in the opposite direction. So now we'll have x to the positive 4 over 1. But again, we don't need to write the over 1. It can just be implied. Okay, now let's go over some of these examples so we can see this in action. To simplify this first one, the first thing I always want to look for is our like bases. And as you can see, I've got one n base, one r base, and one p base. So I don't have any like bases to simplify, so I can then jump right into the negative exponent part of the simplification. So I'm going to just start off with a fraction bar because I know I'm going to be dealing with kind of a numerator, denominator, upstairs, downstairs kind of thing. Some of them will end up here, some will end down there. So I start with that, and I'll just put things where they belong. So I start into the negative fifth, that has a negative exponent, so I need to take the reciprocal. So that's going to come down to the bottom, into the positive 5. And p to the fourth, that's a positive exponent, so I don't have to do anything with that. P to the fourth stays up top. And then r to the negative 2 power, that's going to have to flip, so it's going to have to go from the denominator up to the numerator, from downstairs to upstairs. And that's going to be r squared up top. So my final answer becomes p to the fourth, r squared, over n to the fifth. Take a moment if you need to, just look back over that. The next one, this one's a little more complicated. 5 r to the negative third, t to the fourth, all over negative 20, r to the second power, t to the seventh power, u to the negative fifth power. Lots of stuff, and so in order to kind of simplify this one, I'm going to go ahead and split it up in terms of like bases. So the first one, we'll have 5 over negative 20. Those are my coefficients. Those can usually stick together. So 5 over negative 20. Then that'll be times r to the negative third over r squared. And same thing with the t's, t to the fourth over t to the seventh. And then finally, I'm going to keep u to the negative 5 on the bottom. That shouldn't be a time, sorry. Keep u to the negative 5 on the bottom, and then we'll put just a 1 up top since there's no other u to go with it. That's not it. There we go. That's a 1. I apologize, that's a 1. Now I'm going to go through and simplify each one. So 5 over negative 20, 5 divided by negative 20, if you type that in your calculator, you'll get negative 0.25, or in other words, negative 1/4. I want the fraction. Please give me the fraction. That's not really a request. R to the negative third over r squared. Instead of trying to deal with the flipping right away, I'm going to deal with the multiple r's, the common bases right away, which means I'm going to subtract these exponents. So negative 3 minus 2, what's that come out to? It's r to the negative fifth. Same thing here. 4 minus 7, I end up with t to the negative third. And then, really here I don't have any variable bases that are the same to cancel out. So I'm going to skip ahead here and just go ahead and bring that u to the negative fifth up to the top and make it u to the positive fifth. And that just saves me a step later on and also keeps me from having to maintain the bottom part of the fraction for right now. Once I'm at this point, I can start my final answer. One thing I'm going to do is I'm going to write a big fraction bar again because I'm going to need the extra space. And I'm going to put the 1 up top and the 4 on the bottom because that's how this is going to ultimately end up, right? Just how I have a numerator here and a denominator there, I'm going to have those, they're going to end up in those same spaces. Numerator, numerator, denominator, denominator. Now, r to the negative fifth, that's going to go down to the bottom. Okay. T to the negative third, also going to go down to the bottom. And notice those both become positive once they get down there. And then finally, we already simplified u to the fifth, and it's positive, so it will stay up top. So our final answer becomes negative u to the fifth all over 4r to the fifth t to the third. And that'd be your final full credit, no questions asked, you got it all right answer on a quiz or a test. Okay. Now, I want you, having seen this video, to grab that 7.2b worksheet and do what you can to finish the back of it. Okay, that's the page 12, I believe is what it's labeled. Do what you can to finish that. You got some time in class today, and then you'll be able to work on it some more tomorrow in class with myself, as well as the rest of your classmates for help. Looking forward to it. Thank you, guys.